It is May 2011, paper 1, time zone 1, question 3. It's a question about geometric sequences, and they give you enough information that you can set up an equation because they give you the first term and they give you the sum to infinity. So for part A, we're going to be using our sum to infinity formula, which is u1 over 1 minus r. And in this case, we know u1 is 27 over 1 minus r, and we know that's equal to 81 over 2, because we're told that in the first line. So you really can anticipate what the question's going to be before we've even read it, but the question is find the value of r. So it's just a case of solving this equation. Fairly trivial. Multiply both sides by 2 to give me 54 over 1 minus r equals 81, and multiply both sides by 1 minus r to give me 54 is equal to 81 times 1 minus r. And then divide both sides by 81. 81 divided by 81. 54 over 81 is equal to 1 minus r. 54 over 81 cancels down. It's 2/3. It's 1 minus r. 1 minus something equals 2/3, which must mean r equals 1 minus 2/3, which is 1/3. So that's our answer to part A. R is a third. Part B asks us to find the greatest value of n such that the sigma of Vn, and we're given a new sequence. We've got an arithmetic sequence which has some relationship to the geometric sequence. So our arithmetic sequence, the second term is the same as the second term of the geometric sequence. Well, I've got all the information I need about the geometric sequence. I just worked out for part A that r is a third, and I was told in the question that u1 is 27. So I can work out u2 and I can work out u4. u2 is equal to 27 times 1 over 3, which is 9. And v4 is the same as u4. It's the same as 27 times 1 over 3 cubed, which is 27 divided by 27, which is 1. So my arithmetic sequence must go something 9, something 1, and carry on like that. Now you could set up an equation and solve them simultaneously, but you really should be able to see that the difference in this arithmetic sequence is -4, and we can work out the first term by going back one. So v1 is 13. Now it's possible to solve part B sort of explicitly just by adding up 13, add 9, add, well, the next number would be 5, add 1, add -3, add -7, add -11. And if you did that, if you added up those 7 terms, you'd find the answer is positive. If you added the next term, which is obviously -15, then that would be negative, and you could conclude that the answer is that this expression is positive for the first 7 terms, but by the 8th term it's gone negative. So you can do it explicitly. It's sort of crude, and obviously it wouldn't work if the number was very large, so there is an algebraic method as well. We know this formula. The sum of a geometric sequence is given by this formula. That formula is in your formula booklets. And the question is, for what value of n is that greater than 0? And what's the largest value of n that satisfies that equation? And we're calling that largest value of n capital N. But maybe we'll get to that in a sec. So, n over 2, let's substitute in what we know. N over 2 times 2u1. Well, it's not really u1, is it anymore? It should be v1. So that's 2 times 13 plus n minus 1 times negative 4 is greater than 0. And just tidying up that bracket a bit, I get 30, which is 26 plus 4. In fact, I'll put it in explicitly. 26 minus 4n plus 4, so that's 30 minus 4n is greater than 0. And we're nearly done. We've got to solve this inequality. I can multiply both sides by 2 to get rid of n times 30 minus 4n is greater than 0. And I can divide both sides by n. And that'll give me 30 minus 4n is greater than 0. And just before I finish this, I want to highlight something, which is that we're okay to do the divide by n this time, but you must be careful when multiplying and dividing by unknowns in an inequality, because what if n were negative, then the inequality sign would flip. That should be a fact you know before you start the IB course. We might look at y as we get a bit further in. But if n was negative, then you'd have to think about how this inequality symbol would behave. Fortunately, because n is the number of terms in a sequence, n has to be positive. So I can do this division without worrying about what would happen if n were negative. Okay, and then I can just finish that inequality off. 30 is greater than 4n. N is less than 15 over 2. Therefore, the largest value of n is 7. And that's my answer.